In this lesson, we're going to find the inverse of a function with a restricted domain. Find the inverse of a function with a restricted domain. For the following function defined as 1-to-1, we're going to write an equation for the inverse in the form of y equals f inverse of x, and then we're going to graph both the function and its inverse, and then lastly give the domain and range of both the function and its inverse. So here we're given the function the square root of x plus 5. To find the inverse of this function, recall there are only 3 steps. So step 1 is to go ahead and swap your x's and your y's. So we know that f of x is the same thing as y. So we're going to remove f of x and replace it with an x. We're going to remove x and replace it with a y. When we do so, it looks like so. The next step in finding the inverse is to solve for y. So to get y by itself, in other words, to solve for y, we're going to have to remove the radical symbol. And in order to do that, you have to do the opposite. The opposite of square root is to square something. So we're going to take the square of both sides, square both sides. When we do so, it looks like so. By doing the reverse operation of square root and squaring, it allows you to bring y plus 5 down by itself on the right side, and on the left side you have x squared. Last step to solving for y is to subtract 5 from each side. And then the last step in finding the inverse is to remove y and replace it with f inverse of x. And when we do so, we now have the inverse of the function. So we started out with an original given function, and we ended with the inverse of the function. Okay, let's finish this problem up. We're going to graph both the function and its inverse on the same axis, and then we're going to give the domain and range of each. So starting with the function, it is nothing more than the square root function that has been shifted 5 units to the left horizontally. And note that with square roots, in terms of the domain of what are all the numbers you are allowed to plug in that function, well, you can plug in any number, but the one number you can't plug in, you can't plug in a number that would make underneath the radical a negative. Because remember, with square roots, you can't have a negative underneath, otherwise it would not be a real solution. So what you would do is take whatever is under the radical and set it to where it is greater than or equal to 0, and then solve for x, and that will tell you what are all the numbers you are allowed to plug in. So if we do that, what we would see is that we can plug in any numbers that are greater than or equal to 5. Yes, we can plug in a -5. Sorry, that's greater than or equal to -5. And we can plug in a -5 even though it makes it a 0. Remember the square root of 0, it is a square root, it equals 0. You just can't plug in something that would make it a negative. Now let's look at the inverse of the function. It is nothing more than a parent function of x squared, a parabola that has been shifted down 5 units. So the one thing that you got to remember, and this is a special case, because the domain and range of inverse and their functions, because they swap, that means that if the domain does not include any negatives, neither can the range, because when you swap them, remember, that's going to become the domain which is what it is now, is going to become the range of the inverse of that function. So we have to remember that restriction. So when we draw the graph, we don't want any negative numbers there as well. So it's going to look like so. So you notice that a piece of the parabola there of your second function is missing, and that's the negative side. And you can't have that as a negative side if it's going to be the inverse. Here, these two functions, they do check out as graphed correctly. Notice that they are a reflection about the line y equals x. And there you have the function and its inverse graphed. Now all we have to do is find the domain and range. So let's start with the function itself, and it is indicated so in blue markings. Yes. So the function itself is in blue, its inverse is in red. So let's go back to the function itself in blue to find the domain. How much does it extend to the left or to the right? The domain would be from -5, and it will continue on forever to positive infinity. The range would be from, you got it, from, in terms of how much it goes up and how much it goes down, it would be from 0 and continue all the way up for forever to positive infinity. So actually, once you have your domain and range of your function, all you have to do is reverse that order for your inverse function. So the domain of my inverse, all I got to do is take the range of what my function was, which is from 0 all the way to positive infinity. And to find the range of my inverse function, all I have to do is take the domain of the function itself, and the domain was from -5 to positive infinity. So now that's going to be my new range for my inverse. So again, all you have to do in these cases is simply swap your domain and range. Once you find the domain and range of the function itself, to find its inverse, simply swap them. And there you have it. We have completed all components of this problem.